Hi everyone, welcome back. My name is Loyani, and in the previous video, we introduced signals and used writable signals to manage local component state. We learned how signals make state explicit and predictable. In this video, we're going to build on that foundation and introduce computed signals. So by the end of this video, you'll understand what computed signals are, how they differ from writable signals, when to use computed signals, and how they help avoiding duplicated logic. This is still about local component state, just with a cleaner and more expressive approach. Let's start with a common problem. In many components, we just don't store state. We also derive values from that state. Think about it as a computed value. For example, a label based on a counter, a button that is enabled or disabled based on a state, a filter list based on user input, or as we can see on the screen, the subtotal price for each of the values that we have in the shopping cart. Without computed signals, we usually end up duplicating code or spreading across component, recalculating things manually. So computed signals exist to solve this issue. So what exactly is a computed signal? It depends on one or more signals and recalculates automatically when dependencies change. And it is read-only by design. You don't set a computed signal directly. You do not update a computed signal directly. Angular will keep it updated for us. Going back to the shopping cart example, we have a few items in the shopping cart, each item with different quantities. Each item also has its own price. Depending on the quantity, we calculate the price times the quantity to calculate the subtotal of each item that's in our shopping cart. Also in the order summary, we also have the total quantity, how many items we have in total within the shopping cart, and also the subtotal, which is the average of all the subtotals of each of the items. So each of the subtotals from each of the items and also within the order summary and the total of our shopping cart, all these can be done with computed signals. Just to make this a little bit more clear as well, think about this spreadsheet as your shopping cart. We have a list of items, we have a price of the items, we also have a quantity, and then we have the total, which is basically the price times quantity. So the total itself, we are depending on the cell B2 and C2 to calculate the total for this coffee item. Same thing for the milk. We have the price, which is 2, we have the quantity, which is 1, and then the total is going to be the price times the quantity. And we also have the total, which is the average of the total of the coffee and the total of the milk. If we go to the cell C2, which is the quantity of coffee, if we change this to 3, by the time that we update this, we can see that the subtotal for coffee has been updated as well as the total. So we can consider this column D with the total as being our computed signals. Let's go back to our source code and extend our counter example. Below the count, what we're going to do, we're going to declare a double count. So let's say that we want to calculate the count times 2. We have signal. For computed signals, we have the keyword computed, just like so. We also need to import. So we'll update the import. And here on the top, we also have computed being imported from the @Angular/core. The computed signal also takes on a function. So this function is not going to receive any parameters for now. And inside this function, we're going to pass our signal that we would like to listen. Because again, a computed signal has to derive from an existing signal, one or more. So we're going to read the value from count. So again, in this case, remember, we're not going to access the signal directly. We're going to be reading from the signal. So it's going to be similar to what we have done here on the template. We're going to reference the getter function, which is just treating the signal as a function. And since this is double, we're gonna multiply this by 2. So we have this double count. We can come back to the template. So count, and then the double, and we're gonna make a reference to double count. Again, we add the name of our signal, and we make a reference to its getter function. And here, all I'm gonna do, just add protected, just to make sure that these are all protected. I already have npm run start running. If you don't, just make sure that you run your npm run start or ngserve, and let's go back to the browser to see how this is behaving. So now we have our count and we have our double. So if we click plus, count 1 times 2 is 2, 2 times 2 is 4, and so on and so forth. So when we click on the minus, we are updating. Notice that updates both of them. And if we do a reset, it's gonna do a reset for both of them. So here's what's happening. The double count depends on the count signal. Whenever count changes, double count also updates automatically. There is no manual wiring, no additional code, just using signals and computed signals. Now, you might be asking yourself, why not just use a method instead? For example, let's do this get double count. And here inside, we're gonna return this count times 2. Could we do this? We could. The problem is if we reference the method instead of the computed signal within the template, it's gonna run every time the change detection runs. We're not expressing dependencies explicitly. It can become expensive logic as it grows. Let me make this clear. I'm gonna add a console log, just double count called. We're gonna go back to the browser. We're gonna open developer tools and take a look. Get double count has been called 2 times. Let's refresh this again. It has been called 2 times. We're just refreshing this page. We're not doing anything as of yet. So if we start clicking, again, it has been called twice. It has been called another time. So it's also a double of the calls that are actually needed. This is because it's running every time the Angular change detection kicks in. With computed signals, we only run when their dependencies change. Let's see this in action. We're not supposed to do this. So I'm also going to add double count computed signal called, and I'll return. Remember that we have to return. The arrow function is just a shortcut, an alias to this syntax. So let's go back to the browser. Let's refresh. The double count computed signal was called once. The function was called twice. If we click on plus, the computed signal was called because we changed the value of the signal. The function has been called twice again. And if we reset, it's being called only once. So computed signals run only when their dependencies change and are easier to reason about and also to test. And we're gonna cover tests a little bit later in this course. I'm just gonna comment this out. And I'm just gonna return to its previous code. Another benefit of computed signals is also cleaner templates. So instead of writing logic in the template, because we could write this logic for the double count in the template as well. So the templates stay declarative, meaning they're only responsible for showing things to the user, and components are owning the logic, and the segregation becomes increasingly important as the application grows. A couple of things to keep in mind. Don't try to update a computed signal directly. Avoid side effects inside computed. That console log that we added inside the computed signal, it's a side effect. We should avoid doing that. We use computed signals only for computed values, and if we need side effects, such as that console log, that's where effects will come in, and we're gonna cover effects in the next video. So in the next video, we'll introduce effects, we'll see how to react to signal changes, perform side effects safely, keep state and effects separate. And this completes the core signals trio, the writable signals, computed signals, and effects. If you have any feedback or if you're liking this course so far, please let me know in the comments. Thank you for watching, and I'll see you in my next video.